Hello scholars, welcome back. This lecture we're getting into plate tectonic boundaries. And I will say it again if you've watched a few of my lectures on plate tectonics because I just love this idea. The theory of plate tectonics is the unifying idea. It is the model that explains why we have mountains where there are mountains, why earthquakes occur, how ocean basins form and ocean basins disappear. The theory of plate tectonics states that the surface of Earth is covered by large, rigid tectonic plates. And these tectonic plates move around relative to one another in various ways, and they meet at plate tectonic boundaries. Now, these plate tectonic boundaries is the objective of our discussion today. So we will provide a brief overview of the three types. I will have more lectures that go in depth on each of the individual boundaries, but in order to get it's kind of like a meet and greet. Oh, hello, plate tectonic boundaries. How are you doing? Nice to meet you. I can see that you are a complex entity, but let's just start on the surface. So, large bodies of rock, tectonic plates. Tectonic plates meet at tectonic boundaries. And this makes sense. Okay, so I'm going to bring it close to home. I'm in Fresno, California right now, and I am currently on the North American tectonic plate. If I travel west, I will cross the San Andreas Faults into the Pacific plate. So the Pacific plate and the North American plate meet at a plate tectonic boundary. This is true for all of the plates. There are 15 major plates and a few minor plates that cover the surface of the Earth, and let's talk about them. So, just some facts. Plates move about less than 1 centimeter to over 10 centimeters per year. My fingernails grow at about 6 centimeters per year, and the Pacific plate moves at about 10 centimeters per year. So the Pacific plate is moving a little bit faster than my fingernails are growing. Although my fingernails grow continuously, the Pacific plate moves when earthquakes occur. It happens in punctuated movements, and the movement of a tectonic plate creates an earthquake. Okay, so there are three main types of boundaries: convergent, divergent, and transform. And in our introduction, it's like this. Hold up your hands. Convergent is when two plates meet. Divergent is when two plates move away from each other. And transform is when two plates slide past one another. Convergent, divergent, transform. Let's talk about each of them. So, convergent is when two plates move towards each other. And convergent plate boundaries have two types: subduction or collision. And you could say there's two types. You could say there's two different processes that are going on: subduction and collision. Subduction is when you have two plates meet and one plate is more dense than the other. The more dense plate will subduct underneath the less dense plate. Please see my video on convergent plate boundaries for a more in-depth discussion. But as an introduction, subduction is where one plate descends underneath another plate. Collision is when you have two plates of the same density that then create a mountain range. Examples. Collision, we've got the Himalayas. And subduction, we've got the Andes. Great. Divergent, like this. Divergent boundaries are where seafloor spreading occurs, and it happens at mid-ocean ridges. Part of the cycle of ocean basin formation, how oceans open and close, Wilson cycles, is it starts with the process of continental rift. A continental rift is a divergent plate boundary. And when that continental rift opens up and new oceanic crust is forming, we have a mid-ocean ridge. Here we can see the arrows, my fingers, like this. Okay, nice. Like this, opposite direction. A continental rift opens up. New seafloor starts to build, and then you have opposite continents on either side because the continents have rifted from the continental rift, and a mid-ocean ridge where new ocean floor is being created right in the middle. The mid-ocean ridge system, 65,000 kilometers, the longest, the largest volcanic mountain range on Earth. Pretty cool. Okay. Transform plate boundaries are where one plate slides horizontally past one another, so there's no vertical movement. The Pacific plate borders, or I should say, the tectonic boundary between the Pacific plate and the North American plate through Central California is the San Andreas Fault. The San Andreas Fault is a transform plate boundary. Now, transform plate boundaries have no production. Oh, I've got it here. Okay, so I was really highlighting, we'll say this little notch is going to be the Bay Area. Fresno is about here. North American plate that we see. And then you travel west across the fault, Pacific plate here. Now, the motion is like this, which means that the Pacific plate and the North American plate are sliding horizontally past one another to form a transform fault. Now, this can happen specifically at plate boundaries that may be, let me see, that may be large plate boundaries between big tectonic plates. They can also occur at mid-ocean ridges, which I just checked to see if I have a slide in this lecture. I don't. But I do have a lecture specifically dedicated to convergent boundaries, specifically dedicated to divergent boundaries, and specifically dedicated to transform. So please see all of those for more information. This is what the San Andreas Fault looks like. It's a big gouge that covers the landscape. This is awesome. Check out that cool geology. The San Andreas Fault is the movement of the North American plates over here, the Pacific plates over here, and they're sliding relative to one another, creating a big scar across the landscape where that movement is. And when this thing moves, earthquakes occur. And so the source of earthquakes are movement of Earth's crust that releases energy that propagates through the interior and the surface of our Earth. Now, without a deeper, let's have the discussion. Earth's surface, tectonic plates, are created of either one of two types of crust. Continental crust, which makes up the continents, is thicker and less dense than oceanic crust, which makes up the oceans, which is thinner and more dense. Now, these density differences lead to different types of interactions happening at convergent boundaries, which I discuss in that lecture. But they also create two different types of margins: active margins and passive margins. Now, active margins, these are where plate tectonic boundaries occur, where you have oceanic and continental lithosphere meeting and moving relative to one another. Here's oceanic crust subducting underneath continental crust. You can also have the situation where oceanic crust is joined to continental crust, but there is no plate tectonic boundary. The example here is going to be the east coast of the United States. On the west coast of the United States, we have the North American plate meet the Pacific plate. On the east coast, the North American plate extends all the way to the middle of the Atlantic Ocean, to the mid-ocean ridge. But we go from continent to ocean. That is an example of a passive margin. Continental crust transitions into oceanic crust without a plate tectonic boundary, as opposed to an active margin where continental or oceanic crust meet each other and they move relative to each other. This is the big thing. It's not about, is it different types of crust? It is when you have one type of crust forming a plate, moving relative to another type or the same type, forming a plate, and they move relative to one another, then we have plate tectonic boundaries. And these are important because it is the boundaries that are responsible for earthquakes, for mountain building, for all the active volcanism, for the opening of basins and the closing of basins. And we can look to the Pacific Ring of Fire. A lot of volcanism. So South America, North America, Asia, Australia, the Pacific Ocean. Around the Pacific Ocean, from the Andes up into the Cascades, the Aleutian chain, over here to all these different convergent zones around Indonesia and Japan. This is why there's big earthquakes in the ocean that lead to tsunamis. Oh, we're explaining geological processes through the lens of plate tectonics. That's awesome. And they're occurring at plate tectonic boundaries. Okay, great. So when we have this idea about plates, tectonic plates, and how they interact with one another, then we understand Earth processes from and through the lens of plate tectonics. So plate tectonics is the unifying theory. And if we go a little bit deeper than to just say, the surface of the Earth is covered by large rigid bodies of either ocean or continental crusts, we could say these large blocks move relative to one another and they meet at tectonic boundaries. And the nature of how they move defines what type of plate tectonic boundary there is. There are three types. Convergent, where the plates move towards one another. Convergent, where the plates move away from one another. And transform, where the plates slide horizontally relative to one another. And that is our introduction to plate tectonic boundaries. Thank you.